Hello, good evening. We're going to start fourth class for electrostatics. So we did already cover three chapters. So not three chapters, three classes. First chapter and second chapter is covered to some extent. So the way I am covering again, I will just put it across to you, saying that the I want to keep it as simple as possible, but should be very core physics. Okay. So a lot of things which are basically uh, may put you off in terms of lots of derivations and all. I try to simplify, and some of the derivations which basically are available in the textbook, you can actually figure that out yourself. But the meaning of those are actually forming the real thing. What is the meaning of those derivations? What is the meaning of that formula? Why does it come that way? So these are the things which are actually we will discuss some of those. Okay. Today, what we will do is we have already covered the concept of electric charge. What is the electric charge? We have covered classical. Then we have also covered electric field, the meaning of electric field we have covered, and Coulomb's law we studied in the first chapter classical. Then we have electric flux, so electric field into the area, that electric flux we have covered. And electric field is nothing but electric force based on Coulomb's law, electric force itself per unit charge, that we have covered. So how to think about electric field, how to think about electric flux, those are the things we covered. Then we covered very interesting law, most important law called Gauss law. Then we went into some applications of that. Then in the next classes we talked about electric potential and what is the relationship between potential and electric field and all that we covered. So now the thing that we did not cover till now is a concept called electric dipole. So if you cover the electric dipole and some of the aspects of it, and then move on to capacitor, then we will be covering actually first two chapters of the electrostatics. Now, however, what is that most important thing to understand in this chapter? That is what I am going to do. Now, I will not do a complete detailed derivation regarding electric dipole, which you can always find it in the textbook or in your notes somewhere somebody have. Okay. But what is the meaning of that? Okay. From the physics point of view, what it means. If you really want to understand, those things get covered. Then only it becomes very simple. Okay. So, what we will do is today we will see what is the meaning of an electric dipole, the meaning of electric dipole, and we also will understand electric dipole when it is there, what is the kind of electric field it can produce, what is the kind of electric potential it will produce. Those are the aspects that we are going to follow. Now, what is an electric dipole? First, we'll try to understand what is an electric. The word dipole means what? You have actually kind of studied the word dipole, probably in chemistry. Okay. And also, the word pole is also very much known to you. The word pole is known to you. Polar region, polar bear, you have heard about all those. Okay. The pole is about the the end, terminal. That's what we call pole for a magnet. In fact, if you have a magnet which is basically we write it as north and south. Okay. So a magnet is actually a magnetic dipole. Why is it a dipole? Because it is two poles. One north south, one north, one south. So it's called magnetic dipole. So similarly, you can have an electric dipole. So it has to have two poles and which are opposite in nature, like attractive in nature. So such that you can create. I will create a small piece here in which one side is plus, another side is. So that is called a electric dipole. This is a magnetic dipole, and this is called electric dipole. So what is an electric? What is a magnetic dipole? Two magnetic poles separated by a distance. that is a magnetic dipole, correct? Similarly, electric dipole is two charges, one positive, one negative, separated by a certain, that is called an electric. So, electric dipole, in the electric case, there can be dipoles and there can be monopoles. Monopoles are nothing but the plus charge and minus charge separately available. Till now, we have always studied about monopole, which on the other hand we call it as charge, positive charge, negative charge, separately available. So, they are monopoles. Whereas, in the case of magnetic dipole, only dipole is available, monopole is not available. So, I won't be able to get a north pole, just north pole I want. Can I get it? I won't get it, correct? Just south pole I want, I won't get it. Whereas, in the case of electric dipole, just positive charge I want, I can get it. Just negative charge I want, I can get it. Yeah. So, in the case of electric scenario, monopoles are also available, dipoles are also. However, monopoles, that is what we call charges, are more abundant, and dipoles are also there in the nature. Where are dipoles in the nature? We will look at. Yeah. But in the case of magnetic scenario, monopoles are not at all available in the nature. Only what is available is the dipole, magnetic dipole. So when it comes to next further chapter, we will try to study about, when we do the magnetism study, we will study about magnetic dipole. But now we will only worry about electric dipole. Okay. Electric dipole, how do we now define electric dipole? Electric dipole is defined by two positive charge, one negative charge, one positive. And then let me write it as one small charge here, negative, and one another charge here, positive. Okay. So these two charges, let's say this is minus 2, and this is plus. They are separated by certain. Okay. So these are called. This is called a dipole. So what is important to understand here is these two are somehow fixed, like a magnet. In the magnet, actually north and south are fixed. You can move them nearby because it's rigid, correct? Similarly, even electric dipole, this is somehow fixed, but fixed need not be a metal piece or something. Fixed can be because of certain electric forces which are holding them, or any reason it is fixed. For some reason it is fixed. Yeah, so they don't move away from each other, or they don't move near to each other. Yeah, they are fixed at that distance for some reason. What is that reason? We will see. For that reason, for some reason they are fixed. So there is a so now they so what is the main criteria? Criteria is if this is 2 coulombs plus 2 coulombs, this is minus 2 coulombs. They have to be equal. Like north pole and south pole are equally powerful. They are just opposite. Same way here, plus q and minus q are equally powerful, but they are opposite. Yeah. So if it is minus 2 coulomb, this is plus 2 coulomb. If it is minus 3 coulomb, this is plus 3. If it is minus 2 micro coulomb, this is plus 2 micro. Right. And the distance, generally we take the distance as very small distance, because it is not a distance like so far. It's a very small distance. Then only we care about thinking about that. That's why when only when distance is small, they can be fixed. Like what are the different scenarios where this can happen? Can this happen generally in nature? This possible. It is possible at a very micro level. That's why you have studied it in physics. So you have a molecule called HCl. Okay, HCl means one hydrogen atom and one chlorine atom. They have not made a bond, okay, electrovalent bond or ionic bond. So there is hydrogen is a small one. This is basically the hydrogen nucleus, hydrogen atom. In between there is a nucleus, hydrogen. And then there is a one more atom, which is basically chlorine atom. The big chlorine is little bigger. chlorine. This is H. Yes. So now you can see that chlorine atom has many electrons, hydrogen atom also has only one electron. However, we have to understand that when they come nearby, the hydrogen gives one electron to them and chlorine takes the electron and forms the bond. So when they form the bond, this is H plus and this is Cl minus. So charge is how much for this? So here the charge, it has given away one electron. So that means it had number of electrons is equal to number of protons. One electron and one proton was one proton, one electron was here. Yes. Whereas chlorine has many electrons and many protons, but equal. Okay, so if you understand basically what is the chlorine atomic number, depending on that there are say whatever is the chlorine atomic number, I am going to write it as n protons and n electrons. Same equal. Now what happens is that this one electron will go away from here and this will become n plus 1. Correct? So this has one extra electron. When they were equal, it was electrically neutral. Now it has one extra electron. It has one less electron. So this has become H plus and its charge is 1 positive. 1 means how much? 1 electron 1. The charge of this is basically 1.6 into 10 power minus 19 coulomb. This is the charge of 1 electron. And this one extra electron. So this charge becomes minus 1.6 into 10 power minus. So this is basically minus q, and this is plus, and they join. So after they join, basically they'll join together, let's say, okay, and then there is a distance between their, this distance between their center is the d which we talk. Now you clearly see that we have a scenario in an HCl molecule. How is the HCl molecule formed? HCl molecule is formed by electrovalent bond, where H gives an electron and Cl takes one electron and becomes negative, this becomes positive. And they join together because they are positive and negative, they attract. So there is a distance d between bond length. Now this is nothing but one negative charge and positive charge separated by distance d. So if a negative charge and positive charge which are equal because one is this, one is that, this are equal and opposite, and separated by distance. So this is a dipole. So HCl molecule itself is a dipole. Okay, so it's available in nature. The dipole is available in nature. That is HCl. So there are many such things. This, in chemistry, we can see that there are many molecules which have a permanent dipole moment. We call it as dipole moment. Why do we call it as a moment? We will talk about it. Yes. So this is called, it has a there is a dipole existing. The dipole we don't measure in terms of the coulomb. We measure in terms of dipole moment. That is coulomb into distance. Think about it. Whenever we talk about something into distance, we call it as a moment. The moment of a force is force into distance. Moment of a basically momentum is momentum into distance. Like that into distance when you do, we call it as moment. In this case, it is coulomb into d. So we will write dipole moment p. We give dipole moment p, okay, and write it as the distance between them, that is d, and one of the charges. So this is basically the this is the magnitude of the dipole. Dipole moment is considered to be a vector. So don't put off yourself. So important thing to understand here is that without understanding the concept of vectors, nothing is difficult to understand physics. So please give enough importance to understanding what a vector is. So we have studied many vectors like velocity, acceleration, force, they are all having direction. Like that, this also has a direction. So why? Because positive can be this side and negative can be this side. Or negative can be this side and positive can be this side. So it has some direction. Or it may be one here, one here. So that's a direction. So direction is always from negative to positive. So if there is negative here and positive here, this is the direction of the direction. Please write down somewhere that the direction is given by an arrow from negative charge to the positive. Okay, how to remember that? Always electric field has a direction from positive to negative. Okay, this is the opposite of direction of electric field. Yeah. Always whenever you talk about electric field, we talk about electric field from positive. So here negative to positive. So one we have to define two things for a dipole moment. Okay. It's called electric dipole moment. So dipole moment is a vector. If dipole moment is a vector, we have to understand basically why it is called moment. Okay. Why it is called dipole? We understood. It's called dipole because there are two paths separated by a distance, and that distance cannot be reached. So this is called a dipole. Second thing is we call it as dipole moment. That is the value of the dipole. Because value of the dipole is given by the charge and the distance between them. So dipole moment has to be a product of two. The reason it is called moment is because when you are multiplying certain things with distance, we call it as moment. Okay. So it's called a dipole moment. So magnitude of this is a vector. Magnitude of the dipole moment is 2 into v. Direction of dipole moment is from negative to positive. These three things you will keep that. Whenever we talk about dipole, three things will come to your mind. First thing is about why it is called dipole, because there are two charges separated by distance called a dipole. Second thing that comes to your mind is called dipole moment because there is a distance that you are multiplying the charge, and when you are multiplying, you don't multiply 2 minus 2 and all. One of the charges you take and multiply with it. Since both charges are equal, you can take only one of them, multiply with the distance. Then it's called dipole moment. This is the magnitude of the dipole. It is given by an arrow. Direction of the dipole moment is given by negative path. Three things you understood what is the dipole moment. Now moving forward. And we also found out that electric dipole is nothing but naturally it is available in terms of molecules. Like for example, HCl, we found out that is a dipole because it has H plus ion and a Cl minus ion, each having equal charge. So charge is not about how many electrons are there, it's about how many electrons it has given or so the total charge is equal in top of it. Okay. And then we discuss about dipole moment of that. So dipole moment always it mentioned in your in chemistry basically we always mention about what is the dipole. So we understood. Now, there are many places where dipole moments are like vectors which can be added like vectors. Okay, let us look at the dipole moment of let us say carbon dioxide. So here we saw that H is here and C is here. H and Cl. This is minus plus. So dipole moment is the correct. C is negative to positive. So for this is H. Now let us see basically C both carbon dioxide. What is the carbon dioxide dipole moment? How is the carbon dioxide molecule? Carbon dioxide is like one carbon and two oxygen. O, okay. Oxygen basically is O minus and C is C plus. So they have this is minus plus. So, negative to positive is the P. Right. So, there are two dipoles. You can see there is one dipole here between O and P. There is one more dipole here between O and P. And these dipoles are equal and opposite, exactly equal in terms of magnitude and exactly opposite in terms of direction. Hence, they cancel and dipole moment for this is 0. Okay. So, carbon dioxide does not have a permanent dipole. We call it permanent because it is naturally there. You don't have to do anything to create it. Yeah, but if you take this carbon dioxide and bring it like this, it might have some dipole, but that's not how nature is. Whatever nature is there, in that it has a no dipole. So, what did we do actually? We vectorially added these. So, if this is P1 and this is P2, if I add P1 and P2, we get P. P1 is equal to P2 and opposite direction. Okay. Now, similarly, let's understand the dipole moment of water. So, water, if you take, for example, it is nothing but O and 2H, but it is not in the direction. It's not like this. It is not making a bond, which is basically in a single line. The bond in hydrogen between hydrogen oxygen and hydrogen oxygen here in H2O, it has certain angle. Okay. Water molecule is available like this. So water molecule is from H to H plus O minus. So minus to plus means this is one of them P1. So this is another one. Okay. So there are two dipole moments. You look at how they are. One of them is like this, one of them is P1. Now when you add P is equal to vector addition of P1 plus P, correct? So when you add them, you actually create a parallelogram and get the P. This is our P is to be calculated by adding them in by taking the considering the angle between them. So you basically have P is equal to P1 plus P2 factorial. Means P is magnitude wise equal to P1 square plus P2 square plus 2PC into cos theta. That is the formula that we get. So dipole moment of any particular thing is a vector. You can add them like. So now once you understood what is a dipole and understood what is a dipole moment. Now dipole we know till now we have been always worried and thinking about charges. When we talk about charges, we talk about one single charge. Now here two charges and they are not equal. They are equal and they are equal but opposite. So the dipole moment is calculated by nothing but charge into the distance between. Now if such is the case, then we will now have to calculate what is the electric field around. How does the electric field? Let's understand the electric field around. We know what is the electric field around a single charge, but here we'll try to understand the electric field around a dipole. Okay? Let's see how it. So let us say you take a dipole. I'm going to write the dipole like this. Okay, a slightly bigger one. 1 plus 2, 1 minus slightly bigger. Okay. And the distance between them is. So generally what we do is we take the distance between them as instead of taking D, we take the distance between them as 2A because we want to take one center point. And from here to here we take A. Here to here we take A. Okay. Total distance is 2A. So 2A is same as. So we say 2A mainly because later we don't want 2D by 2 and all those calculations. So 2A means it's easy, A and A. And now we want to find out at some arbitrary point here what is the electric field. You can ask such a question. Now, electric field we know is calculatable by using vector addition. So, we want to find out the electric field here from when we measure the distance from here, from the dipole is a very small thing. Distance between them is in basically micrometers or even less, angstrom. Very small distance between 2 points in an HCl, for example. So, any distance here is a very long distance. Just I want to. So, R basically generally will be very big when compared to A. Most often. So, we want to find out what is the electric field. So, how do I do it? I want to add the electric field because of this and because, but I want to vectorial it. So, for that, what I will do is I will actually join this. So, to find out electric field at this point, we put a unique positive charge and see which side it will go. To put a unique positive charge, it will get repelled by this, and hence electric field will be in this area. E because of the plus. Correct? Now, because of this, it will be attracted to a unique positive charge. So, when it's attracted here, it is towards this E minus. And you can clearly see that E minus Q may be bigger than the E plus Q because this is more near to this than. Now, we want to find out what is the total E. Then I want to basically create a parallelogram and like this is the E. Correct? This is how we calculate. So, when we are actually given the distance R from here and given let us say the theta we can take R and theta distance are given. So, I can specify whichever point we want. Let's say I can specify this point by giving this distance R and this theta. This point R and theta. Whatever way R and theta is sufficient for us to specify a point. So, now if you keep seeing here that what will happen if it is if you want to calculate generically, if you want to calculate the value of electric field, it's a little bit complicated derivation. If you want to derive what is the generically electric field here, so it's somewhat complicated to do this derivation. Okay. So it's doable, but it's a little bit complicated. So in your PUC level, we don't calculate electric field of any arbitrary point wherever you want. So instead of that, we will actually draw two lines. One line we will draw, another line we will draw. Okay, this line we call axis of line. This is called axis. Another line when we draw here, we call this as equatorial plane. Okay, this is called equatorial plane. Please understand that it is a plane, it's not a line. Because two are kept here and it is a 3D space, so there is a plane like it's the equatorial. So equatorial plane and axis. So there are two derivations. Suppose if you want to find out the electric field on this axis, somewhere here at a distance r, you keep your point here, let's say p at a distance r, let me call it point A at a distance r. What is the electric field here? I can tell. And if I keep it at slightly further on the axis, somewhat easier to do the derivation. Or if you keep it on the equatorial plane here at any distance you want, let us say I keep somewhere here p at some distance r, I can calculate. So that the derivation is easy to do. Whereas if you want to keep it anywhere in between, the derivation is little complicated. Hence that is not there. In your syllabus, what is there is two derivations. Electric field when kept electric field when the point is on the axis of the dipole, and electric field when the point is on the equatorial plane of a dipole. In both cases, what is the value of electric? You can move them on that axis wherever you want. So total how much is the electric? So that you can calculate. Now to do that, here is the formula. So I am not going to do the derivation. It is just basically adding that. One is like this, one is like this, add. Yeah. So here also like that, you add two of them, you add. So you will basically get an electric field based on. Okay. So when you add it, you will get two formulas. One for this, one for this. On axis, you got an electric field which is given by E is equal to 2P divided by 4 pi epsilon naught R2. So we try to understand. Okay. And on equatorial plane, we got E is equal to P divided by 4 pi epsilon naught R. Two formulas. One on this line, electric field on this line as a function of the R. Another one, electric field on this line as a function of R. So that is these two formulas. So what is that meaning? First of all, electric field here. So how do you find out what is the electric field? So one of them is this. So what we will do is this one is minus. Okay, this one is minus. So what does it mean? We will look at this here. If you have a distance of let us say 2 centimeters, and here if you have a distance of that is these two are equal. That this R is equal. This value is twice this value, and in the opposite direction. What is the value of dipole? Dipole direction. Dipole direction is also minus the next one. This is the direction of the field. If this direction of the field, then here the direction of electric field will be like electric field will be. And here you can see electric field will be in the direction of P, which is 2P by 4 pi epsilon. So electric field same direction as that. So you realize that electric field at a point on the dipole on this axis wherever you take at the same distance you take here from here to here it is double. So what is the meaning of double? If this is basically electric field is certain coulombs per electric field is given by newtons per coulomb. So newtons per coulomb. Then here if it is 2, here it is 2. Here it is 3, so it's double. So that means in between from here to here wherever you take, it is somewhat middle of the double and the 1 and 2 in the middle. So we can't calculate that, it is a little bit complicated. So we will calculate only for axis and for the equation. So second thing we need to understand here. So what is the first thing we understood? We understood that always on the axis electric field is more for a given distance, double that on the equation. One thing we understood. Second thing is we need to understand that as you go further and further and further, electric field decreases because R is in the denominator. Okay. We have seen that if you take a single charge and you put basically let us say plus Q is there. From here, if you want to find out what is the electric field at this point that is distance R, we say that electric field is equal to Q divided by 4 pi epsilon naught into R square. So as you go further and further here, R will keep increasing and electric field keeps decreasing. Okay, but the relationship is 1 by R. So that means basically if you draw a picture that I showed you last class, this is basically the distance r and this is electric field, it will go down like this. Okay. So E is inversely proportional to R. Whereas instead of one charge, if you keep two charges of opposite value, certain distance, electric field varies as inverse of R cube. Inverse of R cube in the sense that when you actually double the distance, then 8 times electric field will reduce. 2 cube, 8 times electric field will reduce. Whereas this will reduce 4 times, 2 square, 4 times it will reduce. That means basically in the case of a dipole, it may start like this and it will start reducing more drastically, more drastic. Okay. So at a certain distance, keep going farther and farther, dipole will have very less electric. Whereas the single charge, if you had kept, it would have been little more. Okay. So electric field drastically reduces because of the cube. Cube makes it such a way that it basically the cube times this keeps reducing everything. Just three times distance if you go, 27 times it will decrease. So that is how the electric field for a dipole. Even here, same is like will reduce. So that is the difference between electric dipole and a normal charge. Normal charges are generally reduces by square, called inverse square law. Here inverse cube law. Remember. So these are the two important things that. Now the third point that I am going. So I have till now talked about electric field only. So I have not done any derivation for it. The derivation is basically given in the textbook that you can study. I have only told you how to interpret those, how to understand these, because these are equations which have meaning. Don't think that they are just numbers. Okay. What it means is what I am telling you. That's what it means. So now I am going to go and find out what is the potential at any arbitrary point. Potential can be calculated at any arbitrary point. We don't want to wait. We don't want to do only calculation on the axis, on that equatorial plane like that. We don't do. The derivation that we do here for any point, any point you take. Why is it possible for potential to be done for any point? Because potential is a scalar. So we don't have to do vector addition. We just have to do scalar addition. So scalar addition is easy to do. That's why it is possible. So that is why we do simply calculate that at this point. That's why I am going to calculate. Forget about electricity. I'll only calculate V now. Okay. So V due to this and V due to this. I will add. That's I'll simply add. One is negative, one is positive. You can add. So you will get a formula. Okay. What is that formula? Again, I'm not going to do the derivation. Formula is here. V is equal to P dot R into 4 pi epsilon naught R. So look at this. P dot R. P is like this. This is P. R is this. The R, the direction. So these are two vectors. But when I do P dot R, that is P into R into cos theta angle with theta. So when you do that, you will get a scalar, right? P dot R. So and we know that velocity, the potential is a scalar. So as the theta increases or decreases, depending on that, this value the numerator will change depending on the angle. Okay, so we are able to capture the concept of angle here within this dot product. And denominator you see for a charge, for a single charge, P is equal to Q divided by 4 pi epsilon naught R. If you keep a single charge, potential is inversely proportional to R. But if you keep two charges of opposite, plus 2 separated by distance. Then potential varies as R square. So the power in the denominator, whenever you use a dipole for both electric field and potential, the power of R increases by 1 denominator. This is what you have to grasp. So this, if you grasp many of your questions that you can solve in the exam. Okay, so what you need to do is, if it is R here, in the using electric charge, it is R. If you use a dipole, it is R square. For potential, for electric field, normal charge, electric field is inverse R square, and electric field for the dipole is R. You understand this? What are the things you understand? You understand what is the dipole? You understand what is the dipole moment? Why? That also you understood. Its direction and magnitude you understood. And then you understood basically why we cannot calculate very easily dipole, the electric field around the dipole. We will calculate only in axis and the axis because we have to do vector addition. But potential can be easily calculated wherever. So we have the derivation for potential. And how to interpret those derivations we have found. Yeah. So that is all we did. We just understood what a dipole is and how to use the dipole and how to be, where are the dipoles? The chemical molecules, how they are dipoles. Yeah. So I want to actually add one more small concept called as not a permanent dipole but an induced dipole. Yeah, and where the dipole moment is used. These are the two things I will actually talk about. And then we will end this. Numericals also I wanted to do, I will do it in the next time. Because numericals. Yeah. So let's just do the understand basically what is the meaning of a induced. Okay. So if you take a single atom, just let us say atom is there. Atom is basically having a nucleus. Nucleus is all parts, and around which basically there is a sea of electrons. So lots of electrons are there, and whole thing is called basically a atom. Correct? Atom means if there are, let us say, 8, if there are 8 protons, there will be 8 electrons. Correct? So totally, if you see, those 8 electrons are distributed everywhere, and 8 protons are there in the middle. Okay. So if you want to know what is the total dipole moment of the dipole moment, you need two charges, equal and opposite, separated by distance. But there is nothing like that. Okay. It is basically there are 8 charges. We can call it as 8 electrons is equal to 1 charge. So we can call it as 1 charge. So there is one electron charge, one proton charge. Proton charge is positive, electron charge is negative. Correct? So they are not separated by distance. They are individually separated by distance. But since they are all moving around, this, if you take the center of basically the whole charge, center of whole charge is at the center. Okay. So there are equal number of charges on the top and bottom. So the center of the negative charge is at the center. So you have at the center, you have actually a negative, can be replaced by a negative charge at the center and a positive charge also at the. So center has one positive charge, one negative charge. One is 8 electrons. So there is no, it is like saying that two of them have basically same charges at the same place, no distance. Now if you want to calculate electric field, what will happen is that because of the positive charge, electric field will be like, because of the negative charge, electric field will be like, and they will be equal because at the same distance are there, it is also same amount of charge. So total net electric field at this point will be 0. So if you take a normal any atom electrically neutral. So what is the meaning of electrically neutral? Everywhere electric field around it is 0. Why it is 0? Because though positive charges are there, though negative charges are there, positive charges are at the center. Negative charges are distributed equally everywhere so that its center is its resultant center of mass kind of a thing. Center of negative charge. Yeah. So the distance between them is 0. So this electric field. However, let us say I am going to apply certain electric. What is the meaning of applying electric? Meaning of applying electric. I am going to put one plate pass with lot of positive charges. Okay, one plate. Another plate here with lot of negative. Now positive to negative will be the electric. So there will be electric field all everywhere. Yeah. So now what happens? All these negative charges, they will be like attracted towards the positive. They all try to go this way. All these negative charges will be attracted towards the positive. And these positive charges will be repelled by positive charges and try to go. They don't go away because atom is very very powerful. So it holds everything together. It doesn't get out of that. It requires a lot of energy to get that electron plucked out of the atom. It doesn't happen. So this will move a little bit upwards. It will move a little, total will move a little bit downwards. So what will happen is negative charges will come. Center of the negative charges will be here, and actual center of the positive charge will come. The centers of positive and negative charges now are separated by a small distance. Earlier they were coinciding. Now they are separated by distance. Hence what happened? A dipole got created. So dipole got created means called a induced dipole. We induced a dipole. Inducing a dipole actually means there is no permanent dipole before. We induce. So suppose if you take a helium atom, you can make it a dipole by putting electrons. Called a induced dipole. Whereas the other one, HCl, had a normal permanent dipole, natural. Here we have induced the dipole. Correct? You understood? Induced dipole. Now you can calculate the dipole moment by finding out the charge between them and you can measure the electric field because of that. Because the distance from here to here will be different. So now we will have some electric field. So that electric field will be calculated based on this formula. So generally dipole will be available as permanent dipoles in some of the ones, whereas some of them we have to induce it. So we can we have sometimes in the situation where we induce and make it a dipole. Okay. Now, so why do we measure the dipole moment and why do we measure the electric field and all that? We want to also understand how the molecules interact and how do they behave with respect to each other. Why, for example, water is a water. Why water is not a steam in the room temperature. All these things can be understood if we understand the electric force. So they are each one of them are behaving like dipole. Hence there will be electric force between them and they attract and it becomes water. Correct? So one molecule and another molecule they get attracted and it become nearby and hence it becomes a liquid. Whereas carbon dioxide is not a dipole. Hence they will be in the room temperature will be gas. So like that we can understand a lot of things by understanding what a dipole is. So that is basically the story of electricity. We can do some problems. So I would like to do the next class. I would like to do basic textbook problems. I will take the textbook that we use for the NCERT textbook for PUC also. We will take that and the exercise problem. I will take some numericals and just solve them and tell you how to easily solve them, how to understand. It's important to understand. Don't solve a problem just by substituting some value. You have to understand what the problem is. Then you will be able to solve it very easily. Exam by exam. By saying that, I'm going to end this class.